Welcome to week 2 of Introduction to GIS. This week we'll examine more details about GIS and mapping. GIS maps are made of layers of information. These layers are collections of similar geographic features and can represent any kind of geographic information, from elevation to addresses. The layering gives GIS its unique display and analysis properties. Look at the real world. We see that there are many different layer options. When we represent the real world in a GIS model, we're able to visualize these different feature groups as single layers, looking at addresses or water features by themselves, or as a whole, addresses in relation to elevation, roads, water features, and or parcel boundaries. When we look at the world through GIS layers, it allows us to analyze information in a way that is different than analyzing any other kind of data. When the layers are drawn together, spatial trends and relationships often emerge. This allows GIS practitioners to gain insight about relevant characteristics of a location. Viewing the layers together creates a holistic representation of reality. This is truly where the axiom, "the sum is worth more than its parts," reigns true. In this example, we are looking at road proximity, geographically sensitive areas, visual exposure, and housing density. This kind of information would be very helpful to making a plan for future development. I don't know about you, but I would prefer if my city planner looked at all of this data and didn't just use housing density to make development decisions. Spatial relationships are extremely important. A primary function of a GIS is to determine the spatial relationships between different items. The distance separating hazardous waste disposal sites to a hospital, school, or housing development would be an example of spatial relationships. You can also determine features that touch one another, lines that cross other lines, lines that cross other features, or features that overlap with other features. This information allows us to gain a lot of information about the space around us. These spatial relationships can be identified quickly and accurately using a spatial query. A GIS allows you to query features from one layer based on the relationship with features from another layer. For example, which towns have golf courses within their borders? If you were looking at a paper map, you would probably have to count the number of golf courses within a particular boundary. While that works, there's the possibility of human error, not to mention it can be very time consuming. A GIS also allows us to query records based on aspatial data. As we learned it last week, aspatial data is data that does not have a geographic reference and cannot be mapped by itself. Aspatial data queries are the simplest form of analysis. The query usually follows the form of a question. For example, select from the layer all states where population density is greater than 75. This is a typical type of GIS selection query that we will perform in our labs. Identifying these states would allow us to enhance our understanding of the data and perhaps identify any possible spatial relationships or trends. Next, we will discuss cartography and map design. Cartography is defined as the art, science, and technology of making maps. Maps are often considered works of art. Cartographers use this cartographic process to create maps that communicate spatial information clearly and effectively. First, think about the distribution of the phenomenon you want to map and what it might look like. Then, decide on the purpose of the map and the intended audience. Who will be looking at this map and what information do you want it to convey? Then, collect data that are appropriate for the purpose of the map. Design and construct a map using cartographic principles to display data appropriately. The final step is to determine if the map reader understands the map content. This is when you might show a map to a colleague or a friend to make sure that the purpose of the map is well understood by the map reader. A high-quality GIS can be used to design and produce beautiful maps and accurately communicate information. However, GIS can also be used to make extremely bad maps that misinform, introduce propaganda, and even lie. It's very easy for an amateur to make these types of mistakes, and it's important to understand the basics of map design so your final product will efficiently communicate the data to your users. Good map design is learned, it's not inherent. While it is a skill that almost anyone can learn, it does require lots of practice. If you look at the examples here, both are showing the exact same area and the exact same information. However, it's a lot easier to understand the map on the right. The map on the right follows some general map design rules that are important to remember. Map substantial information. The goal is a well-designed presentation of interesting data. It's a matter of substance, statistics, and of design. Communicate complex ideas with clarity, precision, and efficiency, giving the viewer the greatest number of ideas in the shortest amount of time with the least amount of ink in the smallest of space. Don't lie with maps. Tell the truth about your data. If something is missing or if it isn't as clean as you wanted it to be, let people know. Make sure graphics are used in context. Show the variation in your data and not variation in design. Above all else, show the data truthfully. Effectively label maps. Clear, detailed, and thorough labeling should be used to defeat graphical distortion and ambiguity. Minimize map crap. Keep your design clean, remove redundant data, and don't show anything that isn't relevant. Map layout matters. Unless the data suggests otherwise, move toward horizontal graphics that are about 50% wider than they are tall. Evaluate your map. Revise and edit your map to make sure it is conveying what you want it to. Approach colleagues or non-mappy people for help. If you keep these rules in mind, you will have great maps that set you apart from your peers. We try to make good map design choices easy. This is the list of map elements that are found on virtually all maps. Here at UWF, we like to call them essential map elements. Some are fairly self-explanatory. A map title tells your audience what they are looking at or what they can expect to learn from your map. The border or neat line keeps everything organized, delineating and defining the extent of geographic data on your map. The date lets us know when the map was made, in case you have multiple versions, or when the information can be considered out of date. Data source helps people who are using your map know where your data came from. And cartographer name, for the purposes of this course, having your name on the map helps me know who the map belongs to when I'm grading. Some companies have rules regarding whether your name can appear on a map. If so, a company logo may be a good substitute. Some kind of indicator of who owns the map is just good cartographic practice. We will look at scale, legend, and North Arrow in more detail. There are many ways to communicate scale. A traditional scale bar is probably the best bet if your map will ever be reduced or enlarged, because the scale bar will automatically reduce or enlarge as the map is copied. A good rule of thumb is to keep the scale bar simple and keep the units relevant. Units should be easily measured and easily understood by your map audience. Where possible, make sure to include round numbers. If you look at the scale bars in this example, all of them include round numbers that are easily consumable by a map reading audience. Legends showed how data is organized and symbolized. The size and placement of your legend is also very important, and an infinite number of legends may be produced. Items under the legend could be ordered and can be put in any different fashion depending on your personal style and the purpose of the map. Legends can be a lot of fun. When you're feeling creative, play around with it a bit. Try putting different items in different areas. Just make sure that your legend is clear and simple for your users to understand. How do you know what to leave out of your legend? Nothing. If the layer is on your map, it should be in your legend. It's good practice to include a north arrow on all your maps. A north arrow allows your audience to self-orient when they look at your map. Some are very simple, only showing true north. Others also show magnetic north. Be careful with your placement of north arrows. It is not necessary to draw attention to this element. Remember, we want our audience to understand the purpose of our map. Their attention should be drawn to the map itself. When we talk about maps, we use some basic terminology about their qualities or characteristics. Page orientation can be either portrait or landscape, depending on the geographical area of your map. Experiment with both of these to determine the most appropriate page orientation for your specific map. Typography is the font, size, color, and style of the text on your map. You should always keep your audience in mind when choosing your font size and your font type. It's a good practice to keep your font type the same throughout the entire map to create continuity. Make sure your audience can read the text on your map. If it's too small, it will not be useful and it will be difficult to convey any message to your audience. Proper symbology is an important facet of good map design. Point features may be symbolized and mapped using point symbols or colors or a combination of both. Linear features may be symbolized and mapped using a variety of simple graduated mapping. Your selections can either make or break your map. Special attention should be paid to symbolizing area data. Whether it is land cover, soils, elevation, or political or administrative boundaries, the way it is symbolized can impact the way the map user interprets the data. Area data can be thought of as either unconstrained or constrained. County data is a type of constrained data. There is an administrative boundary. Unconstrained data might be something like bodies of water or land use that spans across political boundaries. Unconstrained data is typically symbolized by black and white or simple qualitative color scheme. Just like the example here showing the geology of South Carolina. Constrained nominal, ordinal, or interval data could be mapped as a choropleth map. Grids are either displayed on the map using graticule lines or projection information is provided on the map. Metadata tells us data about the data. Where it came from, its quality, how it was collected, spatial reference information, and any additional descriptive information, including the latency or temporal nature of the data. While it may not be displayed on your printed map, it is critical to your map's success. Look at your metadata when making map design decisions. By knowing when the data was collected, how it was collected, and the type of data, you are ensuring that you are able to represent the information correctly as it was intended by its creator. Metadata should be shared freely to those who ask for it. If you share a map document, the metadata for any layers in the document should be shared as well. It's really important to keep in mind both the type of data you're using and the measurement of your data when you're determining the symbolization on your map. Make sure your map design reflects the theme or topic of your map, your audience, and the type of data you are using, and the measurement of your data. We will go into more detail about spatial data and how it's measured next week, but for now, just remember that many different factors play a part in your map design choices. Above all else, own your map. Think of your final product as art. You have a personal style, you have preferences, and you are unique. Explore and be creative with the cartographic options that are available to you. The opportunity for design is limited only by your imagination. This concludes the Week 2 presentation on map basics and cartography. Please be sure to participate in our discussion of map design, and I hope you enjoy the lab and text exercises that I have picked out for you this week. You'll be able to put many of these concepts into practice, and I look forward to seeing everyone's personal style shine through.